All right, today we are going to crack the code on one of algebra's biggest players, the quadratic equation. But we're not just here to solve for x. We're going to dig in and really understand what solving even means in this context, and why this is such a huge deal for everything from, I don't know, physics to finance. So, you've definitely seen this before, right? ax squared plus bx plus c equals 0. It's the standard form, and yeah, at first glance it just looks like a bunch of letters and numbers thrown together. But when someone asks you to solve this, what are you really looking for? What's the secret that's hiding inside that little variable, x? Well, the answer is a word that's actually a really powerful visual. We are looking for the roots of the equation. And it's a great name for it, because just like the roots of a tree, these are the foundational points where everything starts. Now, you're going to hear a few different names for these. People will call them roots or zeros or solutions, but don't let that throw you off. They all mean the exact same thing. They're just the specific spots where the graph of our equation, that classic U-shaped parabola, literally crosses the horizontal x-axis. And this is exactly why they're also called zeros. Think about it. At that precise moment the curve touches the x-axis, its height, its f of x value, is 0. It's not up in the positives, it's not down in the negatives, it is perfectly, flatly on the line. So when we set the equation equal to 0, we are literally asking, hey, at what x values is the height of this thing exactly 0? This is huge. A business wants to find its break-even point, right? A physicist needs to know when a rocket returns to the ground. They're all looking for that magic moment when the value hits 0. So look, if all the terminology feels like a bit much, just lock this simple image into your head. We are on a mission to find the exact spots where the curve hits the line. That's it. That's the whole game. Okay, so we know what we're looking for now, but how do we actually find them? I mean, how do you pinpoint those exact locations without just, guessing and checking forever? Well, we've got two main ways to go about it. The first path is graphical. You could just draw the parabola and see where it crosses the x-axis. It's really intuitive, for sure, but it's not always super precise. The second path, and this is where we're going to focus today, is the algebraic one, where we use the power of math to calculate the exact value of x. And honestly, the best way to really get the algebraic path is to just walk it. So let's grab an example and find its roots together, step by step. So here's our problem for today. X squared minus 5x plus 6 equals 0. Our mission, should we choose to accept it, is to find the special values of x that make this whole statement true, the numbers that when you plug them in, make that left side equal 0 perfectly. Now, there are a few tools we could use here, but one of the most direct methods is something called factoring. I like to think of it as reverse engineering. Instead of multiplying two things together to get this equation, we're going to take the equation and break it back down into its original, simpler pieces. And when we do that, here's what it looks like. X minus 2 times x minus 3 equals 0. So how did we get here? Well, we were basically looking for two mystery numbers that could do two things at once. They needed to multiply to get us positive 6, and at the same time add up to negative 5. And the only pair of numbers in the universe that can do that is negative 2 and negative 3. Now this right here, this is the crucial step. It's the aha moment. Think about it. If you're multiplying two things together and the answer is 0, then it is an absolute logical certainty that either the first thing was 0 or the second thing was 0. There's just no other way to get to 0 through multiplication. This amazing rule is called the zero product property, and it is the key that unlocks the whole puzzle. So what this property lets us do is pretty cool. We get to split one kind of complicated problem into two super simple ones. Possibility A is that the first part, the x minus 2, is the part that equals 0. Or there's possibility B. The second part, the x minus 3, is the one that equals 0. Now all we have to do is solve these two little mini equations. So for possibility A, if x minus 2 equals 0, we just add 2 to both sides, and bam, we get our first root, x equals 2. And for possibility B, if x minus 3 equals 0, you guessed it, we add 3 to both sides, and there it is, our second root, x equals 3. And just like that, we've got them. For the equation x squared minus 5x plus 6 equals 0, the roots are x equals 2 and x equals 3. And remember, these aren't just some random numbers. If you were to actually graph this equation, you would see that beautiful parabola dip down and cross the x-axis at exactly those two spots. We found them. So being able to find roots is a fantastic math skill, but it kind of brings up a much bigger question, doesn't it? Why do we hunt for zero in the first place? Now that we know how to pinpoint where a function equals zero, what does that point actually mean in the real world? In engineering, in business, in, well, anything. What powerful secrets about the world around us do these zeros really unlock?